This presentation provides an overview of Chapter 7, Part B, in the book titled Simple G, A Gridded Economic Approach to Analysis of Sustainability of the Earth's Land and Water Resources, edited by Aman Hakiki and Thomas Hurdle, and published by Springer. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover a portion of Chapter 7, which is on behavioral parameters, capturing geospatial heterogeneity in economic decisions and responses. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, and discussing the gridded data requirement. In this chapter, we'll focus on behavioral parameters that are critical for this type of analysis. A major feature of Simple G is the multi-scale modeling of economic decisions. In other words, the model measures the economic responses to changes at local, regional, and global scales, as well as how these interact. The behavioral parameters are mainly elasticities that capture how different spatial elements respond to changes in the system. The main parameters include supply, substitution, and transformation elasticity parameters. The flowchart you see on this slide shows the sources of data and parameters for the Simple G US model. The green highlighted boxes are key parameters in this model that do not change during the simulations. The gridded substitution elasticity parameters pertaining to nitrogen and water use have been estimated based on agronomic simulations. The water supply elasticity parameters are empirically estimated based on USDA county-level data and the estimated value of water. Finally, gridded land supply parameters are empirically estimated based on gridded satellite data and county-level observations. The land supply elasticity reflects the sensitivity of cropland area to changes in land rents and tells us how much the supply of land can adjust in response to markets. If the elasticity is high, it indicates that land is responsive to rental rates, for example by converting marginal land to agriculture. A low elasticity signifies limited options for increasing land area and unwillingness to reduce the cropland extent, which could be due to geographical constraints, regulations, or high non-cash benefits of cropland. The water supply elasticity reflects the sensitivity of water supply to changes in value of water in crop production. The magnitude of this parameter depends on availability of water resources, non-agricultural water uses, regulations, and water rights. The substitution elasticity parameters capture how farmers switch between different inputs within the same location, based on factors like prices and productivity. For example, if the price of nitrogen fertilizer increases, how readily can farmers reduce the nitrogen application rate, while keeping production at previous levels, by increasing land under cultivation? Or for instance, if a region experiences drought, can farmers engage in deficit irrigation, and how much yield do they lose when reducing irrigation water? If you're interested in learning more about gridded economic parameters, please review Chapter 7 of the Simple G book, where you'll learn about the sources of land supply elasticity parameters, how to estimate water supply elasticity, and how to inform cropland conversion or transformation parameters. Here, you'll find additional readings and references you might be interested in further exploring. On this slide, you'll find the link to the Simple G webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 7b. We encourage you to explore the other companion videos that accompany the book on the Simple G web page.